Oh, glass, you beautiful amorphous translucent mystery, tell me your secrets. Hello everyone, Julian back again for D News. Physicists from the University of Waterloo, McMaster University, ESPCI Paris Tech, and Université Paris de Troyes all joined forces to answer a long-standing question about glass. And that question was, how does glass form? Yes, even though we've been making it for over 3,500 years, we still weren't sure how or why it formed until physicists from 4 separate institutions solved the puzzle just last month. Apparently, the answer was a lot simpler than anyone had expected, combining 2 older models for how glass molecules behaved. One is molecular crowding, that states that molecules on the surface of the glass can keep moving while the more crowded molecules on the interior can't unless the molecules around it cooperate. This cooperative movement is the second puzzle piece, and it's both helped and hindered by the weak bonds between glass molecules. Taken together, these ideas explain how glass behaves at a molecular level. And believe it or not, it's more tricky than you think. Glass isn't technically a solid, and you may have been told it's a liquid, but that's not true either. It's an amorphous solid, meaning it lacks the crystalline or polycrystalline repeated structures of other solids. This lack of a pattern and the weak chemical bonds explains how glass can behave like a brittle solid, and also accounts for the glass-liquid transition, which is when heated glass is between a supercooled liquid state and a solid state, and it behaves like a rubbery, viscous liquid.
You know, we're taught as children, well, the sun's a gaseous plasma, and we think, well, this is really a modern idea, you know, but actually it goes way, way back. The sun became a gas actually in 1864. You know, we say in the gas model, well, the sun doesn't have a surface. This is just an optical illusion. It's caused by a change in opacity that causes us to perceive a surface there that is not real. Of course, many observational astronomers at the time actually believed it did have a real surface. Warren de la Rue, Balfour Stewart, which for those who know me know that he's one of the people that I have really admired a lot, and Benjamin Lowry, they wrote a paper and they proposed that the continuous spectrum of the sun was consistent with a fully gaseous sphere. So as you know, the sun emits in white light, and they said, well, the gas can do that. And then Franklin and Lockyer, now Lockyer was the founder of the journal Nature, they wrote, the gaseous condition of the photosphere is quite consistent with the continuous spectrum. Now, of course, this was false. A gas cannot give us a continuous spectrum. But today, we still argue that the sun can give us a continuous spectrum even if it's a gas. And these ideas go back to 1865. Now, all our physical knowledge since that time has demonstrated that this is not possible. Yet, we still prevail in saying the sun can give us a continuous spectrum even though it's a gas. And how do we do that? The way that they do it is they say, well, look, we have inside the sun, we have a lot of atoms, and they're in different states of ionization. And through all the sum of many processes, all these processes that we're going to add together, they'll give us that continuous spectrum, like magic. But everywhere else in spectroscopy, and I'm a spectroscopist by training, if you have a certain type of spectrum, you have a distinct process that produced it. So we get an NMR line. So every spectroscopic process that occurs in nature has a specific thing that produces it. Now, graphite produces for us the continuous spectrum. Once you understand why graphite produces a continuous spectrum, then the sun will be bound by the same mechanism. And that will also be true for any other continuous spectrum that you get in nature. This is in 1927. The solar atmosphere is necessarily gaseous since the pressures prevailing are known to be very low at these temperatures, except perhaps the last, there he talks about the corona at 3000, are above the temperature of volatility of even the most refractory known materials, such as carbon and tungsten. Thus, the important conclusion is indicated that the solar atmosphere, with the possible exception of the outer reaches of the corona, no known substance can permanently exist except in the gaseous state. And of course, this is because we have critical temperatures, and it was known that the critical temperature of even hydrogen is extremely low. I think it's like 33 Kelvin. And of course, when these people wrote this, they didn't realize that metallic hydrogen would exist, and that will have a different critical temperature, and so it could be a liquid at much higher temperatures and pressures. So basically, these statements are completely out of date. But if you ask an astronomer, why is the sun a gas? Just ask them, why is the sun a gas? It's a very simple question. And they actually will not be able to answer the question except to say, well, it's too hot to be anything but a gas. If you get the sun wrong, you'll get all of astronomy wrong.
From the earliest times, it has been believed and said that the heavens were not an empty space, but a solid surface. The Chaldeans and Egyptians regarded the sky as the massive cover of the world, and in India and Persia it was thought to be a metallic lid, flat or convex, or even pyramidal. Up to the 17th century, the Earth was always regarded as the center of an empty sphere with solid walls, and on this account, it was always represented with a cover. This indispensable complement, however, was eliminated upon the advent of the theory of gravitation, for convenience sake. As a solid dome limiting the space round the Earth would have rendered impossible the extravagant motions of the planets, which were sent revolving in the air at phenomenal distances. Thus from this time, the fact universally accepted for thousands of years that the sky is a firm surface, completely disappeared. Nevertheless, the possible existence of a solid vault over the Earth is a question of great importance in view of the tremendous consequences which would result from this fact, if it happened to be true. There is no doubt that the general reaction is one of incredulity, but, on the other hand, it can be considered that it is not without reason that the ancients believed in the existence of the material vault of heaven, nor without reason either that this notion should have been consistently handed down through the ages since the earliest times up to the I-70th century, in all parts of the world.
So it's extremely important that we set the phase of the sun correctly. Accepting a new phase for the sun will lead to the collapse of modern astronomy. So if you say that the sun is a liquid, astronomy will collapse. Well, some people say, well, this is a terrible thing. But actually, I think it's good for our children. It will give them some work in the future.
It's almost like these electrons are running into a glass wall in space. Daniel Baker of the University of Colorado Boulder and the study's lead author said,
in 1947, during Operation High Jump, Admiral Byrd discovered the outer boundaries of the firmament. Many of his men's planes were disappearing very quickly. A lot of them were crashing into invisible barriers and disintegrating in mid-flight. It was shortly after discovering this barrier that Byrd discontinued his mission and returned home. What happened is Byrd's planes encountered the walls of the vaulted dome. Soon after, many measures like the Antarctica Treaty and a consistent military presence at the ice wall were put in place to cover up the structure of our enclosed world system, while also preventing unwarranted intrusion which could lead to an announcement of the discovery of the Earth's dome.
And in that film, we show footage of the Navy planes landing in these lakes. But even more so, he found, to his amazement, that his planes were disappearing very quickly. A lot of them crashed into invisible barriers and disintegrated in mid-flight. This is an indication that the Germans had already perfected the force field shields, and they were up and operational around the German colony at Neuschwabenland.
somewhat like the shields created by force fields in Star Trek that were used to repel alien weapons, we are seeing an invisible shield blocking these electrons. It's an extremely puzzling phenomenon.
Each star type, stellar evolution, and galactic formation has to be revisited. A liquid sun would be essentially incompressible by definition. So that means stars cannot collapse into black holes at the end of their lives. Stars don't collapse. Big Bang cosmology will be confronted with limits to maximal densities. So if the sun can't collapse, how do the stars collapse? How do you get material into nothing? There's also a problem for Eddington's proof of general relativity, because remember, and this the citation is there, for Eddington, the corona could be treated as a vacuum. He had to have it as a vacuum. So we have densities there of 10 to the minus 15 grams per centimeter cube, which is, believe me, a very, very powerful vacuum. So remember that the proof of general relativity is that during an eclipse, the light of distant stars as they crossed near the sun was bent, And this became the first great proof of general relativity. But the problem is, if there's actually density in the atmosphere of the sun, in the corona, you'll have diffraction. And so then you don't have a proof of general relativity. The problem is, if there's actually density in the atmosphere of the sun, in the corona, you'll have diffraction. Density in the atmosphere of the sun, density in the atmosphere of the sun, density in the atmosphere of the sun, you'll have diffraction.
It is by this obstacle that the radar waves are reflected, and we may also recall, in this respect, the theory of heaviside leading to the existence of an upper, wave-resisting atmospheric layer.
Density in the atmosphere of the sun.
Wave-resisting atmospheric layer, which is no other than the solid vault of the sky. There is absolutely no solid body between the Earth and the dome of heaven, since the constellations, like the planets, are nothing but luminous phenomena. The meteorites are obviously fragments which become detached from the vault and reach the Earth. These masses, when analyzed, prove to include a high percentage of metal, from which we can conclude that the inherent brilliance of the sky is due to the presence of metals in its composition. The fact is that the Earth, at the beginning of time, must necessarily have become separated from the adjoining mass, which constitutes now the vault of heaven, and, therefore, the parts now divided must contain the same elements. All the metals and ores of the Earth are consequently present in the surface of the sky. An association is actually made between metals and the sky, since the latter is instinctively compared to lead and copper in very hot countries, where broiling temperatures intensify its metallic action, and render it more perceptible. In classical literature, there are two specific references to the metallic nature of the sky, apart from the one to be found in the Egyptian cosmology, but the former may not be independent of the latter. First, we read in the poems of Homer that star-strewn Olympus, dwelling of the gods, is made of glittering bronze. And secondly, in the Old Testament, the prophet Job gives what may be regarded as an exact definition of the sky when he proclaims it to be a mirror of metal. It is to be observed, in this connection, that when poetical reference is made to the silver mirror of the moon, it is the metallic surface of the dome appearing under the transparent disk, which in reality, may be described as a silver mirror. It may further be remarked, that in the mythology of the Orient the attribute of the sun goddess is the sacred mirror. This is another association with the true nature of the vault, and it must be admitted that the latter, especially when it shines and sparkles under the sun, undoubtedly looks like a mirror. It has frequently been observed that there is a resemblance between glass and the sun. In the 6th century BC, Empedocles regarded the sun as a vitreous body, which collects and reflects the light of the ether, but has no luminous power of its own. The British astronomer Palmer, in the last century, held the view that the sun is a lens which, he also said, transmits to us the rays emanating from the Almighty. It is further known that Ptolemy in his system of the constitution of the universe, speaks of the existence of a crystalline sky, that is a sky in the nature of a transparent mineral substance. One may think, in this connection, that it is not impossible that due to the heat developed by the passage of the sun's disk, there may be a fusion and vitrification of the siliceous materials contained in the vault, so that it becomes coated in certain places with a layer of glass, which would communicate to the solar disk by transparence, identical properties, so that it might become similar to a lens. The presence of dross or slag similar to that formed on fused metal, has also been observed on the surface of the sun, which is really, owing to its transparence, the foundation of the sky, and this seems to confirm the possibility of thermal and chemical reactions taking place among the elements, which compose the vault. It can now be understood, that the light and the heat which appeared to be produced by the sun, do not proceed from this source, but are due to a burning glass effect which is generated by the brilliant metallic surface of the vault under the luminous disk. Under these conditions, all the vivifying and beneficial properties, which are attributed to the sun, must be transferred to the solid dome of the sky, as well as the rays. These are not the sun's rays, but they are the rays of the metallic surface of the vault.
So then you don't have a proof of general relativity. So this is, has consequences when you change the phase of the sun. It's much more than just changing how all the stars are. Now, people, I've wrote a paper, got carried away, 40 proofs, 40 lines of evidence that the sun is condensed matter. But actually, there's only one proof that we need. And this proof we've had since the days of Langley, when he first measured the continuous spectrum of the sun. And as I mentioned before, in order to have a continuous spectrum like this, the sun must be condensed matter. You cannot get it from a gas, and I've treated this in detail in this paper, Stellar Opacity, the Achilles heel of the gaseous sun. So you cannot take a whole bunch of non-thermal processes, just random spectroscopic processes, take a sum, a large sum, and then create this spectrum at every layer inside the sun, and until finally you get it on the photosphere. That requires that whatever soup you're building changes constantly within the sun to have the right properties so that it can change the spectrum with temperature. It just doesn't work. So we have Roslin mean opacities, which the solar physicists use to treat this problem, and it's just an excuse for not understanding a process. So you can't do it with a gas, and that's the critical point.
Strange phenomena is being experienced by people globally, the sun flickering and blinking. It's been likened to the flickering of a light bulb just before it burns out. Some have postulated that the flickering may be a camera issue rather than the sun itself, autofocus or exposure settings adjusting when the camera is pointed directly at the sun. That, however, fails to explain people that are witnessing it and actually seeing it with their eyes. In 2009, physicist Gordon Watts wrote about the phenomenon on his blog after experiencing it while on a flight from Seattle to Geneva. His observation was of flickering that was also visible on a portion of the aircraft. After describing his experience, he concluded with, whatever it was very spooky. The sun is supposed to be rock solid.
The flickering sun seemed to raise such a hot debate whether it was, a hoax or people need to really do your research before you let some troll talk you out of doing the research yourself. Just go get a camera. You will find it sooner or later. Let's get right into it. So, on the night of the flickering event in Nigeria, so this YouTuber, captures the same image. Now, I'm going to just let this play through. But what he finds here is the sun blinking. Now, many of you see Nigerian sun blinking. And take the sun is out of focus. If it's been out of focus, then I expect it to get blurry, right? You should actually literally physically see it change focus. That's not the case in these videos, but I'm going to skip ahead that he does his own investigation. So he shows people with their hands above their head and looking at the sky. You can review it, the whole video yourself. It's all over, and I'll leave a link to this one. And you could see people with their signs in their eye. Okay, so they're not freaking out, but let's just get to the video evidence. So we see this thing flicker. And he keeps looking at the sun. This guy puts his glasses on. And you can pause it very carefully. This got his hand in there. He's looking. It's obvious to everybody here. The whole sky is flickering. See this guy here? He's covering his eyes to look at the sun. Now, how you look at the sun. So he records it himself. I believe it was at the same time. Let's watch what he had to show. Here we go. So you can see his flashing sky. There's so much to see in this video. I want to show you countless evidence of the flickering or the pulsing sun, the blinking sun. Now, you see that thing changing size, and yet you do not see in the distance. If he was using autofocus, then this should lose focus. The leaves are crystal clear in the background, and it still pulses.
Like everywhere, all over, and then, oh, look at you, blinking. The thing blinks all the time.
Whoa. What the heck?
So as it comes out through the bottom of this junk, sunny side up. Let's see what happens. Let's just by itself. Well, look at it move. Is it just me, or is it like moving to the left? The camera's not panning at all. Oh, look at blink. Go, go, blinking sun. You can blink all day long. Go, blinking sun. You can do it. Wow, it's going nuts.
So what is happening with our sun? In 2012, it was reported that a huge portion of our sun had flown off and was hurtling towards Earth. While coronal holes are not unusual, something as large as this is unusual. Almost 2/3 of the sun was missing. When looking at the image, it's absolutely startling. Many say, well, that's just what it looks like through a filter, as if that would negate the fact that a large portion of the sun is gone. Filter or not, the dark areas represent areas of the sun that are missing. Corey Powell of Discover Magazine makes that perfectly clear.
This part that's missing, the reason it's dark, is that whole chunk of the sun basically ripped off, blew out, and is coming our way at about 2 million miles an hour.
Our way?
Our way.
That doesn't sound good. That doesn't sound good. Know this before? Or did we not take note of it?
Well, we know it's really very recent that we've even been able to see these things. What this means is this is what the sun does all the time, and we don't really know why it does it.
Because of buoyancy, helium and hydrogen rise. Therefore, there is a tremendous amount of those elements in the stratosphere. There is the ozone layer filled with O3, oxygen, and there is the magnetosphere. The magnetosphere can ionize the air, and obviously a magnet can have a profound effect on light. This effect is called the Faraday effect. It's where the polarization of light is rotated while it travels through transparent materials. There are many lab experiments to show electromagnetic effects on light. Also, this is a field that requires a lot more study. Some scientists say that magnets don't affect light, but consider that light is moving at extreme speeds, so a single magnet may not be too noticeable. However, a giant magnetic field, such as the Earth's field, can certainly affect light. As you can see, buoyancy absolutely must separate the elements of greater densities. This means that NASA is clearly not telling us the truth about the elements contained in the stratosphere, and they are probably not telling the truth about the air pressure there either. When hydrogen and helium rise, they obviously do not disappear. No, they settle at the top and they stay there. It is almost unbelievable to say that nitrogen is the most common element in the sky when there is so much helium and hydrogen rising. Not to mention other combinations thereof. Take a look at our buoyancy diagram. This is what we call a density gradient. The cutoff lines are actually pretty clear. Let's take a look at a density gradient in a laboratory. Here we can see that the light is bent downwards and then it is bent upwards. In fact, they even split the beam of light and recombine it later. Pretty amazing, right? Still not convinced? Take a look at this clip from the North Pole sun mirage. They see the sun during a time of the year where it should have been impossible. It may be due to the magnetic pole or some other refractive phenomenon. There have been many experiments to show how light can bend up or down in our atmosphere. Over the water, it would be more probable that light bends downwards very slightly near the ocean line as light descends. This is because, as you get closer to the water, the amount of water particles increase. This increase in density causes light to go from a refractive medium to an even more refractive medium. This is called Snell's law. This could add to the list of possible causes for cities to get cut off at the bottom over the waterline. So we can see that hydrogen is 4 times more refractive than helium, and lucky for us, hydrogen is more buoyant. So for the 300 or more miles of atmosphere, depending on how high you guess the sun to be, light will travel significant distances bent upwards towards the observer. Extreme heat or cold from the sun can certainly forge elements, such as helium hydride or even stranger elements. It's fair to say, unless parts of space reach negative 300 degrees, we will probably not see liquid hydrogen. However, on the internet, people seem to say in some cases atmosphere is extremely cold. It creates an inversion layer, supposedly. Maybe it just depends on where the sun is. It has been estimated that there is helium hydride in the stratosphere, however. Now, if we consider that hydrogen is above helium, this element will form a nice little lens compounding the amount of refraction that the light experiences. Even a thin layer would be significant. Imagine the light passing through hundreds of tiny little lenses. In order for helium hydride to exist, it must be in an excited state, and I think the tremendous heat of the stratosphere would be a good catalyst for this. I would like to see some experiments done with refractivity of exotic materials like these. I expect it to be significant. You see, an element on its own is not even close to the refractive index of a combined element, and the direction of refractivity may indeed change depending on the combination. For example, water is significantly more refractive than hydrogen or oxygen on their own. Why the dramatic change? Because the elements form a little lens. Let's take a look at the periodic table sorted by density. Using this, we can know how some of the elements will be ordered in the atmosphere and what direction light will bend for each layer. But don't let that dominate your calculations, because what matters is the amount of miles light will travel at the angle before crossing into the next medium. Also, it matters greatly the different materials in the atmosphere. Do not limit your bias to elements only. Refraction increases dramatically when you combine elements. For example, how does ozone affect and refract light, and how thick is the layer? Don't count on government space agencies for honest statistics here. For example, when light goes from helium to lithium, lithium is only 0.23 refractivity, and helium is more than 4 times more refractive. So again, light refracts upwards, and quite significantly. Lithium passes to argon, and light will refract downwards, and it will go down again from argon to nitrogen, and then again slightly from nitrogen to oxygen. Also, if astronomers avoid filming stars 20 degrees above the horizon because of refraction, that alone is enough to prove to you that their calculations of parallax are not scientific or reliable. If you triangulate a 10,000 kilometer sunset at 300 miles high to the ends of the stratosphere, we get a 2 to 3 degree angle of sunset. This certainly makes the sun easier to block with air. In fact, anything within 10 degrees is worth discussing. Another reason why this subject is so important is because it can potentially explain why the moon only shows one face. Flat earthers tend to ignore this problem. The moon, no matter where you stand, shows the same side. What type of magic holography is this? Well, if you consider that the atmosphere is potentially bending light towards the observer, then it makes sense that a flat light would change its angle towards us in the atmosphere. Let's take a look at some different types of holography while we are on the subject. Here you can see a coin appear on top of a cylindrical base. No matter what perspective you view the mirror, it looks like the coin is sitting on top of the base. Try to grab it, it's not there. The trick is in the mirrors on the inside, a brilliant little design, like a cylindrical pepper's ghost. Of course, there are almost endless ways to design a system like this. Now let's take a look at lumographic lenses. These things are completely awesome. Depending on the angle that you view the lens, you can see a different image. This type of lens is an art form. And here is Castayer augmented reality glasses. They use two projectors and reflect them off of a retroreflective surface back to your eyes. Everyone sees a unique image. Anyone can make a pyramid hologram at home. Here I filmed a holographic moon myself using a simple pyramid made from my transparent sheets. For those people who theorize that there is a dome or firmament above us, whether it is made of ice or any other material, that could definitely reflect light back to the observer at various angles. In addition to reflected light, there is projected light. Light from a projector expands as it moves away from you. However, this also depends on the shape of the lens. A flat light source like a television screen would cause almost no increase in size as you move away from it. Perhaps this is why the moon and sun have a slightly round appearance. It would also be another possibility to explain why the sun does not shrink as much as people anticipate. Also, the further you are from the sun or moon, the sharper the angle is to them and the greater the refraction. Also, the more miles the light must travel through the thermosphere to reach you, and the more profound a small change in angle will be. Have you ever seen a moon set? Have you noticed that it almost always seems to move faster in the sky the last few moments as it descends? The sun seems to do the same thing. Right before sunset, it quickly drops a few degrees. Why? Finally, on this subject, we can see hundreds of examples of sundogs, double suns, double moons, and other things like this in the sky. It's hard to make sense of these sightings and decide which ones are valid. However, multiple suns is a pretty common occurrence. Also interesting is the alleged sighting of Rahu, which is a semi-translucent disk said to be the cause of eclipses. Something similar to this could cause the moon's phases. Or, considering that the sun and moon are constantly refracted, this introduces a wide new range of possibilities for the moon's phases.
So Planck commented on the solar spectrum years ago, and people don't, Planck has done a lot in science, and people, they quote scientists when they want, and they decide not to quote them when they don't like what they had to say. But here, Planck says something to the solar physicists of still today. He says, now the apparent temperature of the sun is obviously nothing but the temperature of the solar rays. Now he's talking about the continuous spectrum. Depending entirely on the nature of the rays, and hence a property of the rays and not of a property of the sun itself. So he's telling you, this is not a property of the sun here. Therefore, it would be not only more convenient, but also more correct to apply this notation directly, instead of speaking of a fictitious temperature of the sun, which can be made to have meaning only by the introduction of an assumption that does not hold in reality. So Planck knows that in order to get a valid temperature, you have to follow the laws of emission. And those laws require certain things. You can't have convection. You can't have conduction. Now, is there convection on the sun? Well, clearly there is. Carrington showed us that there was convection a long time ago, right? We see the sunspots going around. The sun has convection currents. So that forbids you from taking a temperature. So that's against the laws of emission. You have to have enclosure, thermal equilibrium with a rigid enclosure. The sun never meets that requirement. Now, I like this slide because this slide, for people who can't understand the continuous spectrum and all the physics of, how do you get a continuous spectrum and spectroscopy, and they're not interested in this, and it's all foreign to them. But this one is so easy, right? So if this is a flare, it's a Doppler image of a flare. So the white that you see here is a flare that's coming out of the surface of the sun. And as it breaks the surface of the sun, you see these ripples that are going out. Now, in the paper, they actually talked about this resembles ripples on a pond. Well, ripples on a pond are transverse waves, right? Now, you only get transverse waves in condensed matter.
Oh! Nearly 4 million of us had our minds shattered by the bending glass.
Pours nicer than aluminum.
Oh yeah, it's a lot smoother than aluminum.
It is boiling and bubbling though like crazy.
Of course, it's a pre-burnt hole already. We already poured
aluminum or
aluminium or whatever you want to call it in there.
I'm not English. It is aluminum. It's kind of forming like a crystallized layer. Come here. Come here. Bring the camera. Come in close, everybody. Let's just talk about this here. It's kind of got a crystal layer up on the top there.
It does.
Kind of weird.
It didn't catch fire like I expected it to.
No, it didn't catch fire at all. Which I'm not sure if that's just because it's the salt or
was it pre-burnt maybe?
Yeah, maybe. It's kind of bubbling up there.
No, there's still more in the ladle, right?
Yeah, there is still more in the ladle.
Now, you only get transverse waves in condensed matter.
Oh!
So once you have a transverse wave, gases can only sustain longitudinal waves.
It is boiling and bubbling though like crazy.
I have the large spot Fresnel lens set up. Right now we are working on a rock. What I've done is placed a rock under there and we're making backyard lava or obsidian. It is a black glass-like structure that usually only occurs around volcanoes. What I'm going to do is just gradually drop the heat so it doesn't bubble very much.
The British astronomer Palmer, in the last century, held the view that the sun is a lens which, he also said, transmits to us the rays emanating from the Almighty. It is further known that Ptolemy in his system of the constitution of the universe, speaks of the existence of a crystalline sky, that is a sky in the nature of a transparent mineral substance. One may think, in this connection, that it is not impossible that due to the heat developed by the passage of the sun's disk, there may be a fusion and vitrification of the siliceous materials contained in the vault, so that it becomes coated in certain places with a layer of glass, which would communicate to the solar disk by transparence, identical properties, so that it might become similar to a lens. The presence of dross or slag similar to that formed on fused metal, has also been observed on the surface of the sun, which is really, owing to its transparence, the foundation of the sky, and this seems to confirm the possibility of thermal and chemical reactions taking place among the elements, which compose the vault. It can now be understood, that the light and the heat which appeared to be produced by the sun, do not proceed from this source, but are due to a burning glass effect which is generated by the brilliant metallic surface of the vault under the luminous disk. Under these conditions, all the vivifying and beneficial properties, which are attributed to the sun, must be transferred to the solid dome of the sky, as well as the rays.
So let's try to burn some stuff. And we got instant fire. And that didn't take too long to start melting the surface of the rock there. There it is.
That's the dirt turned to lava. This nail, it's actually welded to the rock now.
It's kind of forming like a crystallized layer. Come here, come here. Bring the camera. Come in close, everybody. Let's just talk about this here.
Some think there's a layer of Libyan glass 100 kilometers up that gets overcharged. I don't agree, but we should look into this glass. In the Libyan Egyptian desert, this is like a 200 kilometer range. You can see there's tons of this, what they call Libyan glass. Each piece looks like it's been chipped off another piece, off another layer of glass. They're clear and pure with some meteoric dust in them. The sand and rock native to the desert has a red hue and high in iron, unlike this Libyan glass. It can't be fused by the local sandstones. It's a completely different chemical composition to the local environment. And at the local meteor site 150 kilometers away, they didn't find any there. So there's like 1,000 tons of this most natural glass ever found. And it takes up to 1700 degrees before it starts to melt. That's over 500 degrees higher than any other natural glass. If it's dropped in water when red hot, it doesn't disintegrate.
Libyan desert glass, mysterious shards of a glass-like material which, according to the scientists, has an unknown origin, are pieces of the dome that have been shed. Libyan desert glass is unlike any other glass. It is a form of molten glass but has no clear layers of other minerals. It is 98% molten silica. It has an extremely high formation temperature of 3092 degrees Fahrenheit. So it's extremely resilient, like any dome above us would be. Perhaps this is the molten glass described in the Bible's book of Job. Hast thou stretched out the heavens, which are strong, and as a molten glass?
Good afternoon. This is Universal News Media. It is January 25, 2018. On the morning of January 3rd, 2018, residents of the sleepy little town of Cheakamus Canyon in British Vancouver, Canada, got to enjoy not one sunrise, but two. The entire double sunrise was caught on video, which we will be playing momentarily, by the Canadian Aviation Weather Cam located at Cheakamus Canyon Tower. These photos are unedited, untouched, raw footage of what came from the Canadian Aviation Weather Cam. We will now begin the video of the double sunrise in time-lapse mode. Each frame is 10 minutes. The entire video happens over the course of 2 hours and 10 minutes. As you can see, it starts out looking like only one sun, but as it rises over the mountaintops, it actually splits into two completely separate suns. The second sun that you will see in the video is, at least in part, causing our red sunrises and red sunsets to occur each and every day. This is not normal. In the past, either the sunrise or the sunset was red, not both. The reason that this sunrise does not appear red is because the sun actually rose over an hour ago and we are seeing it rise above the mountain later in the morning. For those who were able to see the earlier sunrise in this area on this morning, it was indeed very red.
The one on the left is from Alaska, clearly showing what I would say would be two suns. Now, you could say, oh, you took that through double pane glass. Okay, I'll give you that. Possibly could be some kind of refraction. But look at the one that I got from Ireland, you guys. This photograph came from Ireland from a few days ago. And look at this. This is cray-cray. What I'm showing here cannot be a lens flare, guys. It's sitting behind the pole, first of all. You can see it's not a reflection or refraction of this object. So what are we looking at here, guys? Are we looking at a planet? Are we looking at a shield? Are we looking at an artificial sun, real sun? What are we looking at? And I would say maybe all the above, or maybe none of the above. But at the end of the day, when you see something like this, you know, the hypothesis could go wild, right? So I am just going to say this is an unusual photograph of a phenomenon that shatters your world perception. And when that happens, your beliefs get challenged, and some of your beliefs even get destroyed when you start to really open your aperture to what's really happening versus what they try to tell us is happening out there.
Flip. So there's a sun and he's going to be doing his second trial run here, hoping for a better time than his first and a better score than that.
Okay guys, here we are back at the video, and the sun should be completely past the horizon now at this point because it's like 8:30. Okay, and it's not. That's the problem. Okay, so now it is starting to get past the main border, and as it does, I'm just going to focus on this whole time. You watch. There's something else trailing behind it and setting. And it's leaving streaks of light, and it's leaving a circumference of something, and you're gonna see, and it's gonna freak you out. And I'm just gonna shut up for this part. That's the incandescent filter right from my camera. That's the neon filter right from the camera. That's the auto filter. It's what the computer selects by as much visible light. That cloud ship right there is bizarre. Look how bizarre it's even more bizarre it's getting as light reflects through it. Crazy stuff. Let me move my big old head out of the way so we can see. Crazy stuff. Look at the light at the top of it, like the bright light at the top of it. Look at this too. Look at this like weird vortex opening too. Very strange. Oh, it's finally starting to break past the horizon line. Because when it does, you're going to see something yellow about right there start to drop. Very slowly, I might add, and it has a red rim around it. So it looks like a faint yellow sun. Maybe our real one. Maybe the visibility was just right because I did something else too that I hope works out. I went outside and filmed the firmament when there was just a little bit of light. I'm zooming at the brightest star where there's still a little bit of light from the sun. So if you could zoom in at on the firmament when there's just a little bit of sunlight, you may be able to see it. And that was my theory. So I zoomed past the brightest star. You can tell I'm really zooming hard. I'm going to get to that point. And then all of a sudden I get to the firmament and I can see patterns. And we're going to get to that. Okay, so for now, this is this. Wow. Wow. Okay, now this thing is totally, completely broken past the horizon line. And I'm just going to stay on this spot. Let's make sure we got another hour, a minute and 42, but it's playing a little faster, so about a minute left. So just hold on, guys. There is definitely something right there. Now I'll move the paint. Now just watch it now, because what they passed off with the sun today has already broke past this line. There's something else right there. Just keep watching it. I mean, it's obvious that there is something round and yellow there, right? I mean, the trail of light that the two left, the artificial sun and the real sun, the trail of light just let you know that there was a block of lights there, and hence the reason why the sky is so clear, but yet they chemtrailed just for sunset. I think that's all I got, guys. Stay tuned for some more incredible stuff. Okay guys, here comes the star. That's Sirius, okay? Let you know that I have the capability of zooming deep into stars, which means with the right light I can zoom into the firmament, and that's what I do. I go past this star right here. Look at that. I went past the star, turned up the brightness, and there's the texture of the firmament. And I even zoom even deeper and keep the star in frame. There's the star to the left. Here's the deeper texture of the firmament. Can you believe this, guys? There's the firmament, raw deal. Amazing. Not only did we get a secondary light source setting, but as the sky was still bright from a sunset that should have set a half hour before, I said, what the heck, I got my telephoto camera that can zoom 160 times its normal visual. I show you I'm zooming in at a star, and then I start zooming past the star, leaving part of the star in frame, and you can see texture of the firmament. I finally got it, and what I was waiting for was a day where there was no clouds and great visibility. I watched the news broadcast. I waited and I waited and I waited till finally I could use that telephoto camera towards something positive, which is finding the firmament. And I'm glad you guys stuck around for it.
So this image is enough. A child can easily tell us the sun is not a gas once you see this image. So I was going to talk about Kirchhoff's law because actually you can't really understand the sun without dealing with the problem of Kirchhoff. It's important to remember that a proper understanding of black body radiation is important as it touches virtually all aspects of physics, from the study of condensed matter to the understanding of noise power and MRI, which got me into this mess in the first place, to fundamental astronomy, to setting the temperatures of the sun using thermal spectra. So it's extremely important. This law is old and it has huge implications in physics. But the problem is that the law is not valid. It has no experimental proof. When Kirchhoff wrote the paper, it was all theoretical. There was no theoretical proof of what he was, there was no experimental proof of what he was saying. But a law of physics can only come from experimental proof. Kirchhoff had none. Such proof doesn't exist today. But a further problem for physics is that the theoretical proofs are invalid. There are no theoretical proofs of Kirchhoff's law. So last year, along with Steve Crothers, we went over Planck's proof of Kirchhoff's law, and we discovered that to arrive at Kirchhoff's law, Max Planck inferred that the reflectivities of two arbitrary materials were equal. So if you look at his book, which is cited here below, his equation 40 is that the reflectivity of one arbitrary material is equal to the reflectivity of another. And that's a complete violation of all of known physics. The reason that we see colors is because reflectivities are not equal. They're never equal. The reflectivities of two arbitrary materials are never equal. So Planck could never properly arrive at this equation, but nobody caught him on it. This equation has been sitting in an important physics book for 100 years. Everyone can understand it, right? It's just A equals A prime. It's the same thing, or R equals R prime. These two reflectivities of two arbitrary materials are equal. Planck tells us the reflectivities of all arbitrary materials are equal. That's a violation of all of known physics. Now, in Planck's world, what does this mean? In Planck's world, there are no colors. In Planck's world, there are no colors.
Even though we have polarization of the sun through something, so that you only need one polarizer to make a rainbow when you can't do it in your house with a natural light in your house. It's kind of funny, actually. So there's like a lot of things that don't make sense. There obviously has to be something above us, some sort of dome, for there to be a rainbow with just one polarizer, raindrops. If you take raindrops and you take mist and spray it in your house with just a normal light in your house, like a light bulb, you won't get a rainbow unless you're looking through a mirror, because the mirror is the second polarizer. You have to have some sort of crystalline structures above us for there to be polarized light coming in. Okay. So I mean, all these things don't make sense. You wouldn't have radio transmissions in 1915 without satellites if we're on a convex ball. Okay. And I just covered the rainbows and halos and all that. Halos, you can see them often at nighttime. Just go look up at the moon, and you'll sometimes see a halo around it. What it is there's crystals high up in the atmosphere, frozen crystals, and it's not them alone that makes that halo effect. Okay, it takes two polarizers to make any type of rainbow or halo effect, and they just don't tell you that in school. They don't tell you that stuff, because then you'd be like, well, what's the other thing causing it, and they don't want you to ask those type of questions. So
this is where physics has taken us to this state. Because of Kirchhoff's law, Planck's equation has never been linked to the physical world. It's a little complicated to understand, but every equation in physics has to be linked to an underlying mechanism. There has to be a physical cause. But Planck was never able to link his equation because, according to Kirchhoff, the means of generating the black body spectrum was independent of the nature of the walls. It didn't matter what the box was made out of. So Planck was never able to make a link. And this is a huge reason why astronomy is so messed up today. Planck's violation of the laws of reflectivity. And then also the fact that Kirchhoff tried to tell us that without experiment, that his law was valid. How do you make a law of physics without any experiments to prove it, prove it, prove it?
where sprites are that just seem to make some sort of halo effect when they hit it, like as if there's a barrier there. Why do radio transmissions bounce off it? Well, it's because it's a different atmosphere. It doesn't really make sense. Why does it actually look like there's something physically there?
Now, mainstream science says sprites are plasma discharge events, said to do with the vacuum of space connecting with our atmosphere. But, as many flat earthers know, there is no space.
Prove it. Prove it.
It reaches altitude, hits the firmament, boom, starts curving, turns around and falls.
Prove it. Prove it.
Because this is where the magic happens. So now, when I take my torch and shine it into the half of the mirror that's underwater, and on this card that I've placed here, you get the rainbow. How cool is that?
Prove it.
Now, of course, when debunking science, expect to see some deceptions. There's a video circulating on YouTube which seemingly demonstrates a rainbow being reproduced indoors. Now, as we've already seen, rainbows require a second reflector. In the case of this video, the second reflector is the giant puddle and metal plate on the ground.
Prove it. Prove it.
All right, so this is Indoor Rainbow, take 4. We had some flat earthers who disagreed a little bit with my setup, so I'm going to run the video through again, this time without the metal pan, which was on the floor. I had a metal pan underneath there before, and somebody said it might be reflecting, so we're not going to have that there anymore. All right, so we have a LED light bulb, the front of which is very flat, no curvature. Flat, no curvature.
Flat, no curvature. Flat, no curvature.
And it's a daylight bulb, 5,000 Kelvin color temperature, pointing down at an angle from a high location in my pole barn. And this is the water setup here. We've got misters coming in, 2 misters, one up top, one down here, and a valve to turn it on and off. All right, Austin, hit the light. And we got to turn off the overhead lights. And we've got curtains over the windows, no sunlight coming in. All right, leave the light on, bud. Turn the light on. There we go. All right, so we've got the sun. There's our sun spotlight. And, all right, hit the water. Bailey, hit the water. Austin, you can leave the light on. All right, so here we go. We're gonna see if we can see a rainbow. There we can see it already. There we can see it already. There we can see it already.
Oh wow, it's so easy to get one outside. Don't even have to try, man. Come here.
Oh wow, it's so easy to get one outside. Don't even have to try, man.
I don't see a rainbow yet.
There we can see it already. There we can see it already. There we can see it already.
Bingo.
In Planck's world, there are no colors.
This is where the magic happens.
Oh wow, it's so easy to get one outside. Don't even have to try, man.
In the end, Kirchhoff's law of thermal emission is not valid as it has no experimental or theoretical proof. As a result, the foundation of the gaseous sun collapses. And that's why I've spent so many years on Kirchhoff's law, people wondering, why does he care so much about a law of 1859? And that's the reason, because now let's say, just look at your own lives. If there was a law that said, well, if you're British and you come and drive in the United States, you're not allowed to drive on the right. You must drive on the left. That would not be a good law, right? So the same thing here with Kirchhoff's law. What happens when a law of physics is not correct? And we have built all of modern physics upon it. That's a problem. That's a problem.
Fishbowl was part of Operation Dominic. It looks like they are sending high altitude nuclear bombs to test the fishbowl of the Lord, i.e. the firmament. Yeah, this is definitely one of those things to make you go,
In the exact same time period, Russia is also testing the dome. The Soviet Union's K project was a group of 5 nuclear tests conducted in 1961-62. They were all high-altitude tests fired by missiles of the Kasputin Yar launch site in Russia.
A variety of instrumentation to collect effects data was set up for Fishbowl. All in all, of the 266 Fishbowl instrument stations, 156 were on land, while 10 ships housed 80 separate project stations. 15 test aircraft carried the other 30 stations. Refraction effects from a nuclear burst are of concern in the high-precision target tracking of ICBMs in the terminal phase, involving a rapid fluctuation in the apparent angle of arrival of returning radar pulses. It was present on all events, but most pronounced on bluegill and kingfish.
Whoa. What the heck?
Change when actually the population says, we don't believe you guys anymore. Great discoveries in science don't occur because we spend a lot of money chasing things that seem fanciful. They occur because some quiet scientist somewhere that everyone has ignored has been in the lab working, and that person made a discovery which led to new understanding.
In the 1990s, Dr. Robitaille set what is possibly the most important world record for nuclear magnetic resonance imaging. When they said the power required to use 8 Tesla magnets to improve cranial MRIs would pose a major electromagnetic risk to the patients, he showed that they were wrong, and he did so by exploiting some of the key mistakes physics has made over more than a century. His discovery is credited with saving tens to hundreds of thousands of lives, all because he refused to take the standard science for true. He hunted it down, found the mistakes in history, and so what do you do after you've changed your entire field and medical service forever? You see where else those mistakes you found have been applied in science, and it just so happens, nowhere has it been more instrumental to our current understanding than on the Sun. The same physics which, when corrected, saves lives by incredible numbers, has now been applied to our star.
This is definitely one of those things to make you go,
Although we weren't able to shatter that highest, hardest glass ceiling this time, thanks to you, it's got about 18 million cracks in it.
Do you know what the strongest material on Earth is? You probably guessed diamond, right? Well, in some sense, you're right. It is commonly referred to as the hardest natural substance on Earth. But, as with most things, this answer is vastly oversimplified. First, hardness, and strength, is not a single property. Materials can be very strong in one way, but not another. Some resist scratching better, while others can absorb force better. And then there are new synthetic materials that combine many of these properties. So let's get to it. I'm Mike with List 25, and these are the 25 strongest materials known to man. Diamond. This is the classic. Of course, keep in mind that in this case, hardness refers to scratch resistance. In the Mohs scale, a qualitative scale that measures the resistance of various minerals, a diamond comes in at a 10. This scale goes from 1 to 10, with 10 being the hardest. A diamond is so hard that other diamonds have to be used to cut it. 24. Darwin bark spider silk. Often referred to as the toughest biological substance in the world, though this claim is now being contested by another biological material, the Darwin bark spider's web is stronger than steel and tougher than Kevlar. Equally as remarkable is its weight. A strand long enough to encircle the Earth's diameter would only weigh half a kilogram. 23. Aerographite. This synthetic foam is one of the lightest structural materials in the world. It's about 75 times lighter than styrofoam, but a lot stronger. This material can be compressed to a 30th of its original size without any damage to its structure. Another way of looking at it, aerographite can carry up to 40,000 times its own weight. 22. Palladium microalloy glass. Developed by scientists in California, this substance has almost the perfect combination of toughness and strength. The reason for this is that its chemical structure counteracts the brittleness of glass, but still maintains its strength. 21. Tungsten carbide. Tungsten carbide is incredibly hard and has really good yield strength, but it's quite brittle when it's bent or smashed. 20. Silicon carbide. This is the basic material used in battle tanks. Actually, it's used in almost anything that deflects bullets, grinds, or refracts. It has a Mohs hardness rating of 9 and also a low thermal expansion. 19. Cubic boron nitride. Roughly as strong as diamond, cubic boron nitride has one major advantage. It's insoluble in nickel and iron at high temperatures. For this reason, it can be used to machine those elements. Diamond forms nitride with iron and nickel at high temperatures. 18. Dyneema. It has been claimed to be the strongest fiber in the world. Perhaps the most amazing thing about it is that, in spite of being lighter than water, it can stop bullets. 17. Titanium alloys. Titanium alloys are extremely flexible and have really high tensile strength, but aren't quite as hard as steel alloys. 16. Liquid metal. Developed at Caltech, this substance is very well rounded in terms of strength. It's basically a jack of all trades, but a master of none. It has high levels of hardness, tensile strength, and resistance to fatigue. 15. Nanocellulose. Made out of wood pulp, this new wonder material is stronger than steel. It's also cheaper. In fact, nanocellulose has been considered as a less expensive alternative to glass and carbon fiber. 14. Limpet teeth. Earlier I mentioned how the Darwin bark spider's web was one of the strongest biological materials on Earth. However, limpet teeth are proving to be even stronger than spider webs. The teeth of limpets, aquatic snails, are extremely tough. They need to be, because they're used to remove algae from rock surfaces. Scientists believe that in the future we could copy the fibrous structure of limpet teeth and use it in cars, boats, and even aircrafts. 13. Maraging steel. This substance combines extreme strength and toughness without losing malleability. It finds many uses in aerospace and tooling technologies. 12. Osmium. An extremely dense element, osmium is used for things that require a high level of durability and hardness. Electrical contacts, fountain tip pens, etc. 11. Kevlar. Used in everything from drum heads to bulletproof vests, Kevlar is almost synonymous with hardness. Kevlar is a type of plastic that has extremely high tensile strength. In fact, its tensile strength is roughly 8 times that of a steel wire. It can also withstand temperatures of around 450 degrees Celsius. 10. Spectra. High-performance polyethylene is basically really strong plastic. This lightweight, strong thread can withstand an incredible amount of tension and is 10 times stronger than steel, pound per pound. Similar to Kevlar, Spectra is also used for ballistic-resistant vests, helmets, and armored vehicles. 9. Graphene. As an allotrope of carbon, a 1-atom thick sheet is 200 times stronger than steel. Although it looks like saran wrap, good luck busting through it. You'd have to balance a school bus on top of a pencil on top of the graphene in order to poke a hole in the sheet. 8. Bucky paper. This nanotechnology is made of carbon tubes that are 50,000 times thinner than human hair. This explains why it's 10 times lighter than steel, but 500 times stronger. 7. Metallic microlattice. The world's lightest material, metallic microlattice is also one of the lightest structural materials on Earth. Some claim that it's 100 times lighter than styrofoam. As a synthetic and porous, yet extremely strong material, it has uses in many fields of engineering. Boeing is mentioned using it in the fabrication of planes, mainly in the flooring, seat frames, and walls. 6. Carbon nanotubes. Carbon nanotubes, CNTs, are, in simple terms, seamless cylindrical hollow fibers that are made up of a single sheet of pure graphite. The result is an extremely light material. At the nanoscale, carbon nanotubes have exhibited strengths of 200 times that of steel. 5. Aerographene. Also known as graphene aerogel, imagine the toughness of graphene combined with unimaginable lightness. You can't imagine it, can you? Well, let me make it even more unimaginable. It's 7 times lighter than air. This incredible material can recover completely after more than 90% compression and can absorb up to 900 times its own weight in oil. There's hope that this material could be used to mop up oil spills. 4. As of yet unnamed substance under development at MIT. As of this recording, scientists at MIT believe they have found the secret to maximizing graphene's 2-dimensional strength in 3 dimensions. Their, as of yet unnamed substance, may have roughly 5% the density of steel, but 10 times the strength. 3. Carbine. In spite of being just a single chain of atoms, carbine has twice the tensile strength of graphene and 3 times the stiffness of diamond. 2. Wurtzite boron nitride. This natural substance is produced under the intensity of volcanic explosions and is 18% harder than diamond. It's one of the only 2 naturally occurring substances that have recently been found to exceed diamonds in terms of hardness. The problem is that there isn't much of this substance out there, and it's hard to actually test it. 1. Lonsdaleite. Also known as hexagonal diamond, this substance is also made of carbon atoms, but they're just arranged differently. Along with wurtzite boron nitride, it's one of 2 natural substances that are harder than diamond. In fact, it's 58% harder. As with the previous substance, however, it's in relatively short supply. It's sometimes formed when meteorites containing graphite impact the Earth.
Prove it. Prove it.
Asteroids are terrifyingly powerful, but they're also incredibly interesting and slightly misunderstood. Now, we tend to use the terms meteors, comets, and asteroids interchangeably, but they are very different, even though they tend to come from the same place. An asteroid is a relatively small rocky body that orbits the sun. A comet is a relatively small object whose ice can vaporize from the heat of the sun, forming what we sometimes see as that trail of dust and gas behind it. A meteoroid is a small piece of comet or asteroid. A meteor is the light phenomena from when a meteoroid enters our atmosphere and vaporizes. And a meteorite is what survives coming through our atmosphere and subsequently crashes into Earth's surface. Scientists estimate that the kind of meteorite that hit here in Arizona happens every 300 years. And actually, asteroids coming to our atmosphere is quite common. Every other week, a 3-foot diameter asteroid comes to our Earth, hits the atmosphere, and then burns up. A car-sized one comes about once a year, breaks apart, and forms bolides, the technical term for fireballs. Really, any asteroid 82 feet in diameter or less won't make it to the surface. Sometimes they come close though, like in February 2013 in Russia. The giant fireball or super bolide was estimated to be 59 feet wide. Luckily, it broke apart before hitting our surface, but it was still able to blow out windows and injure over 1,000 people.
One thing I really want your generation to embrace is that the Earth is a closed system. We cannot leave the Earth. There's no place to go. The Earth is a closed system.
The Earth is a closed system.
We cannot leave the Earth.
We cannot leave the Earth.
We cannot leave the Earth.
Meteor se uvijek pojavljuje kao svjetlost kružnog oblika koja padajući kroz atmosferu ostavlja iza sebe svijetleći trag u obliku tanke linije. Prilikom pada, glava meteora se povećava, širi i pojačano svijetli, potom ekspandira u veliki sjajni bljesak. Na kraju se meteor potroši, raspadne na nekoliko manjih dijelova koji odmah nestaju ne dodirujući tlo. Meteori se najčešće pojavljuju na visinama od 90 do 150 km. Nikada nije zabilježeno da je i jedan meteor pao na tlo, a visina nestajanja meteora događa se obično na visinama od 40 do 60 km. Svjetlost meteora ne dolazi od vatre zapaljenog kamena, nego od elektriciteta. Meteor je vrsta električnog pražnjenja. Električno polje je neprekidno prisutno u visokim slojevima atmosfere, a zrak i atmosferski plinovi ponašaju se kao vodič električnog polja. Prilikom pražnjenja elektroni i ioni se gibaju, ubrzavaju, međusobno se sudaraju i umnožavaju zbog djelovanja električnog polja, koje se širi čitavom putanjom sve dok se glava meteora ne pretvori u električni sjajni bljesak. Uslijed sudaranja atoma s brzim česticama elektrona i iona povećava se temperatura u meteoru. Atomi prelaze u viši nivo energije koji se manifestira jakim bljeskom svjetlosti, slično kao kod pojavljivanja munje. Meteor se raspada zbog smanjene provodljivosti na nižim gušćim slojevima atmosfere. Utvrđeno je da se s padom visine smanjuje broj pozitivnih iona u atmosferi i naglo opada jakost zemljinog električnog polja. S povećanjem tlaka na nižim slojevima atmosfere smanjuje se električna provodljivost zraka. Pozitivni ioni u sudaru s elektronima, atomima i molekulama gube svoju energiju. Povezuju se u električki neutralne atome i nakon kratkog pobuđenog stanja atom se vraća u osnovno niže energetsko stanje. Putanja pada meteora je dijagonalna, pojava meteora je iznenadna, najčešće nečujna, ali ponekad se prolaskom meteora čuje parajući, krskajući zvuk sličan grmljavini. Kretanje meteora je iznimno brzo, kreću se brzinom od 10 do 40 km u sekundi, a vrijeme od pojavljivanja do nestajanja obično traje nekoliko sekundi, a može trajati i 20 sekundi. Meteor nije zvijezda padalica, meteor je električno pražnjenje. Ovaj meteor je iskričast kao električna varnica. Kojim znanstvenim metodama su došli do zaključka da je ovo kamen koji se raspada? Meteori su atmosferska pojava, a ne svemirska pojava. Meteori ne dolaze iz vanjskog svemira jer da je tako odlazili bi i dolazili u svim smjerovima, ali one uvijek padaju prema nama. Električno pražnjenje se manifestira kao svjetlucanje raznih boja u okolini aktivnog električnog polja, a ovisi o temperaturi, tlaku i sastavu zraka. Tragovi meteora mogu se pojavljivati u raznim varijacijama boja, narančasto-žuta, zelenkasto-bijela, plavo-zelena i srebrna. Sjajni bljesak meteora na kraju putanja nije eksplozija kamena kao što kažu da jest, jer onda bismo vidjeli vatru, kamen kako leti i raspada se na manje komadiće. Za nastanak vatre potrebna su 3 elementa: toplina, gorivo i kisik. Kamen ne gori, ne može biti gorivo. Velika brzina kretanja kamena kroz zrak ne može proizvesti dovoljno topline da ga zapali. Nije moguće da se kamen koji je otporan na požar prolaskom kroz atmosferu može trenjem zraka zapaliti, ispariti i eksplodirati. Ako, kao što možemo sami zaključiti, promatranje meteor nije kamen nego elektricitet, i ako nijedan meteor nikada nije stigao do tla, znači da nije moguće da meteor napravi krater. Meteori koji padnu na zemlju nazivaju se meteoritima. Ako nijedan meteor nikada nije pao na zemlju, meteoriti ne postoje. Pojava nekih meteorskih rojeva može se lako predvidjeti jer se ponavljaju svake godine u isto doba, što znači da postoji prirodni mehanizam po kojem se oni pojavljuju uvijek u istom vremenskom periodu. Prolazak električnog pražnjenja kroz atmosferu stvara stup visoko ioniziranog zraka, oblak pun električki nabijenih čestica iona i elektrona, koji je nastao gibanjem elektriciteta kroz plinovitu tvar.
Слышишь? Это знаешь, что было? Это он сверхзвуковой, это похоже астероид.
Meteorski rep se formira tako što električno pražnjenje kroz atmosferu, to jest prolazak jakog električnog polja i svjetlosti, stvara zagrijan i visoko ionizirani zrak i nestabilno kemijsko stanje u atmosferskim plinovima, koji su zbog djelovanja topline pretrpili kemijske i fizičke promjene svog sastava.
Это взрывная волна дошла, видимо.
Meteori koji ostavljaju rep koji se zadrži pojavljuju se u malom omjeru u odnosu na ukupan broj meteora koji su viđeni. Prestankom djelovanja električnog polja i oni stvoreni u atmosferskim plinovima najčešće se brzo rekombiniraju i vraćaju u prijašnje stabilno normalno kemijsko stanje. Mjerenja promatrača pokazuju da atmosferski uvjeti, gustoća zraka i atmosferski pritisak utječu hoće li prolaz meteora ostaviti rep koji će se zadržati ili ne. Veće su šanse da se meteorski rep zadrži ako se meteor pojavi na većim visinama gdje je tlak zraka niži, što ga čini veoma električki provodljivim. Bez imalo sumnja možemo utvrditi da ovaj rep meteora nije dim od vatre zapaljenog kamena kao što kažu, jer dim od vatre se odmah rasprši. Parajući zvuk meteora ne dolazi od otpora zraka dok kamen pada kroz atmosferu, nego su to električki prenešeni zvukovi nastali širenjem plinova u vodiču meteora. Glasan prasak i pucketanje koje čujemo ne dolazi od eksplozije kamena, nego od naglog širenja plinova. Prilikom prolaska električnog pražnjenja, temperatura u vodiču meteora naraste do iznimno visokih temperatura. Uslijed različitih temperatura unutar i van vodiča električnog polja meteora, atmosferski plinovi se naglo šire što izaziva pucketanje i prasak. Ova dvostruka pojava meteorskog repa je zbog toga što je na rubovima traga električno polje snažnije. Dužina repa meteora varira od 10 do 50 km, a širina repa od kilometra do 6 km. Meteorski rep koji se zadrži obično ostaje vidljiv 15 do 30 minuta, a ponekad i nekoliko sati nakon nestanka meteora. Primjećeno je da rep meteora ostane plutati zrakom nošen vjetrovima i pritom zbog atmosferskih strujanja vjetra na tim visinama mijenja formu i formira se u razne čudne oblike. Eksplozivno širenje zraka uzrokovano je njegovim zagrijavanjem visokim temperaturama zbog prolaska električnog pražnjenja. Naglim eksplozivnim širenjem zraka stvara se udarni zračni val kao u Čeljabinsku, dovoljno jak da izbije vrata i prozore. Osim crtanih animacija i Photoshop slika, u kojima komet prikazuju kao veliki krumpir od leda i kamena, izgleda nemoguće pronaći originalni snimak ili fotografiju pada kometa. Teško je objasniti nešto što nigdje ne možete promatrati. Svjetlost kometa može doći jedino od elektriciteta. Ova kuglasta munja posjeća na komet jer za sobom povlači raspršeni rep. Znanost kaže da kometi mogu trajati 1.000.000 godina prije nego što se rastope i nestanu. Najpoznatiji je Helijev komet koji se navodno svakih 75 do 76 godina vraća u orbitalnu putanju blizu Zemlje kada postane vidljiv i može se promatrati. Zadnji put se, kažu, pojavio 1986. godine, a prije toga 1910. godine. Pogledajmo što su rekli astronomi koji su čekali najavljenu pojavu Halleyjeva kometa 9. veljače 1986. Astronomi diljem svijeta su razočarani jer se komet nije pojavio. Čak je i NASA morala priznati da Halleyjev komet nije bio vidljiv. Nakon malo istraživanja može se otkriti da je Edmund Halley bio istaknuti mason. Neobjašnjivo je kako Halleyjev komet bez energetskog pogona i inteligentnog navođenja sa slučajnom kaotičnom putanjom može preći udaljenost od nekoliko milijardi kilometara i vratiti se svakih 75 godina u istu orbitu. Edmund Halley nije pogriješio u svojim proračunima, nego je plasirao namjernu laž. Halleyjev komet će se pojaviti sljedeći put 2061. godine, dovoljno da sljedeća generacija zaboravi prevaru s pojavom kometa 1986. A kamoli da znamo što je bilo s kometom davne 1910. godine. Kuglasta munja je oblikom slična meteoru, kreće se sporije i ima nepredvidive smjerove kretanja. Iza kuglaste munje najčešće ne ostaje svjetleći trag. Kuglastu munju se često i dan danas zbog neznanja i nerazumijevanja prirode povezuje sa NLO-ima. Kažu da su asteroidi kao i meteori kamenja koja se klasificiraju kao asteroidi nakon što dostignu dimenzije veće od 25 metara. Sasvim sigurno kamenja koja lete i kruže ispod nebeskog svoda ne postoje. Ako su meteori i kometi električna pražnjenja, znači da nije bilo masovnog istrebljenja dinosaura i života na Zemlji izazvanog padom kometa, meteora, asteroida i da takva opasnost ne postoji. Teorija da su ključne sastojke potrebne za život na Zemlji prije nekoliko milijardi godina donijeli kometi, asteroidi i meteori, sada se može odbaciti. Odakle onda dolaze ovi takozvani meteoriti koji su pali s neba? Ovo nisu kamenja, izgledaju kao da su odlomljeni od istog takvog komada, izgledaju kao da su inteligentne izrade i dizajnirani sa svrhom. Nazivaju se palasite meteoritima. Karakteristika im je da se sastoje od peridot dragulja, željeza i nikla. Palasite meteoriti se po nazivu svrstavaju u klasu kameno-željeznih meteorita. Peridot dragulji su jedina vrsta dragulja koja se pojavljuje u palasite meteoritima. Dragulje unutar matrice su veličine od pola milimetra do nekoliko centimetara. Peridot ili olivina je dragi kamen, zelene maslinaste boje. Kada je okrenut suncu, teži sjajiti u zlatno-žutoj boji. Palasite meteoroid jepara težak 500 kg pronađen je 2008. u Indoneziji prilikom građevinskih iskopavanja na dubini od 3 metra. Pretpostavlja se da je pao davno jer je na njemu vidljiv vremenski utjecaj oksidacije. Kada se meteoroid jepara izreže na manje komade, dobiju se ovakvi odresci. olivine ili peridot dragulji čine 64% sastava jepara meteorita. Esquel meteorit ukupne mase 755 kg pronađen je u Argentini 1951. godine. Ovo je jedan fragment Esquel palasite meteorita prepun peridot dragulja zarobljenih u matrici od željeza i nikla. Najveći pojedinačni komad Esquel meteorita težak je 680 kg i skoro svi postojeći dijelovi su rezani iz ovog jednog komada. U ovom fragmentu Fukang meteorita su peridot dragulji koji se nalaze u matrici od željeza i nikla. Kada se matrica od željeza i nikla okrene prema suncu, dobije se efekt plavo-bojanog stakla s draguljima zlatnog sjaja. Dio ovog meteorita koji nije okrenut prema suncu, nego se nalazi u sjeni ispod šešira, je ostao sive boje s draguljima blijedog sjaja. Fukang palasite meteorit ukupne mase 1003 kg pronađen je 2000. godine u Kini, raštrkan na mnogo većih i manjih fragmenata u planinama pored grada Fukanga. Novčana vrijednost najvećeg primjerka Fukang meteorita teškog 420 kg cijeni se na $2 milijuna. Palasite meteoriti, kako ih pogrešno nazivaju jer misle da potječu od meteora, su u stvari odlomljeni dijelovi plavo-sive kupole prepune dragulja ispod koje živimo. Kupola kao da je stvorena po konceptu matrica od željeza i nikla s draguljima sprijeda i iza nje željezna konstrukcija koja je podržava. Sve što se odlomi od kupole padne na zemlju. Svi meteoriti dobivaju ime po mjestu gdje su pronađeni. Palasite meteorit Imilak, Čile, ukupne mase 820 kg, pronađen je 1822. godine.
This is one of the largest slices of any palasite meteorite in existence. Not the largest, but it's certainly one of the largest. This is a slice of the Imilak palasite, which is from Chile. And you can see very clearly the very beautiful matrix of iron and nickel metal, and embedded within that these absolutely fantastic crystals of the mineral olivine, which is an iron and magnesium silicate. And in fact, in the olivines in Imilak and palasites like it are actually of gem quality, so you could actually call them peridotes or peridots depending on how you wish to pronounce that. But really, really beautiful specimen. And we think that these meteorites formed on asteroids, and we think that these formed in the insides of asteroids. So with the Barwell, beautiful sort of lime greeny yellow colour of the olivine crystals in this.
Spectacular.
They really are. These are probably the most stunning of all of the meteorites.
Dijelovi Brenham meteorita su pronađeni 1882. godine, raštrkani u više masa na području gradića Brenham u SAD-u na nekoliko desetaka lokacija ukupne mase 4,3 tone. Odlomljeni komadi kupole pojavljuju se oštećeni zbog pada s velikih visina. Najveći dio pronađene mase većine meteorita otpada na metalnu konstrukciju koja podržava prednji dio kupole. Željezo kupole često jetkaju, kemijski nagrizaju razrijeđenom kiselinom kako bi se očitovala struktura metala. Time se uništava prirodna ljepota kupole. Kada se pronađeni dijelovi kupole jetkaju, pokazuju pravilne linije nazvane Widmanštatenove figure. Pronađeni dijelovi kupole se pojavljuju kao pojedinačni dijelovi metalne konstrukcije, kao matrica s draguljima i konstrukcija zajedno. I pojavljuju se kao matrica od željeza i nikla s draguljima pojedinačno. Meteoriti se po nazivu dijele na kamene, željezne te kameno-željezne. Analiza željeznih meteorita pokazuje da se sastoje većinom od željeza, zatim nikla, te ostalih metala poput silicija, kobalta, germanija, titanijuma, indijuma, bakra, cinka, kroma i nekih minerala. Najveći pojedinačni komad meteorita na svijetu je Hoba u Nambi težak 60 tona. Zbog svoje mase nikada nije pomaknut s mjesta na kojem je pronađen. Hoba je željezni meteorit koji se sastoji od 84% željeza i 16% nikla s tragovima kobalta. Najveći je prirodni komad željeza na svijetu. Željezni meteorit El Chaco najveći je fragment meteorita Campo del Cielo, Argentina. Nedaleko njega pronađen je još jedan fragment težak 30 tona. Na području širokom 3 km, dugačkom 18,5 km, pronađeno je još na tisuće manjih fragmenata koji s ukupnom masom od 100 tona čine meteorit Campo del Cielo, najvećim na svijetu. Željezni meteorit Anigito težak 31 tonu, najveći je fragment Cape York meteorita teškog 58 tona, pronađenog 1894. na Grenlandu. Željezni meteorit Akpalilik težak 20 tona, drugi je najveći fragment Cape York meteorita. Nalazi se u muzeju u Kopenhagenu. Željezni meteorit Canyon Diablo iz Sjedinjenih Američkih Država ukupne težine 30 tona pronađen je 1891. godine, razbacan u tisuće fragmenata. Njegov sastav je željezo, nikal, fosfor, galijum, germani, indi i minerali. Njegov najveći fragment je Holsinger meteorit težak 639 kg. Željezni meteorit Armantikina težak 28 tona pronađen je 1898. godine. Željezni meteorit Willamette iz Sjedinjenih Američkih Država težak je 14 tona. Sastoji se od 91% željeza, 7,80% nikla s tragovima kobalta i fosfora. Neobičan je jer na sebi ima metalne spojeve koji kao da služe za pričišćavanje za metalnu konstrukciju. Željezni meteorit Bakubirito, Meksiko, pronađen je 1863. godine, težak je 22 tone. Njegov sastav je oko 90% željezo, 7% nikal te fosfor, indijum i germani. Željezni meteorit Cupaderos 1 pronađen u Meksiku težak je 14 tona. Nedaleko njega pronađen je Cupaderos 2, težak 6700 kg. Željezni meteorit Mundrabilja Australija, ukupne težine 24 tone, pronađen je 1911. godine. Najveći fragment težak je 12 tona, nedaleko njega pronađen je manji komad težak 6 tona. Željezni meteorit Mbozi, Tanzanija, težak je 16 tona. Njegov sastav je željezo, nikal, silicij. Poltuski je željezni meteorit koji je pao 1868. godine u Poljskoj. Tisuće ljudi svjedočilo je pljusku s neba tisuće malih željeznih fragmenata koji su pali na područje veliko 127 kvadratnih kilometara. Procjenjuje se da je palo oko 70.000 fragmenata težine od pola grama do 9 kg. Ukupna masa Poltusk meteorita je oko 9 tona. Primjerci meteorita najčešće su pronalaženi razbacani u više fragmenata, ali ponekad u samo jednom komadu. Poput meteorita Palasovka, Rusija, 198 kg, Jepara meteorit 500 kg, Hoba meteorit 60 tona. Većina pronađenih fragmenata raspona od nekoliko miligrama do nekoliko tona pronađena na područjima velikim, ponekad i desetke kilometara, što ukazuje da se prilikom odlomljavanja dio kupole raspao na više manjih komada i nastavio se raspadati prilikom pada. Odlomljeni dijelovi kupole su padali brzinom slobodnog pada i uslijed otpora zraka prestali su ubrzavati nakon što su dosegli stalnu brzinu pada. Osim lokalnih šteta na mjestu pada, nije zabilježena nikakva destrukcija okoliša jer nije se mogla stvoriti brzina pada koja bi stvorila razarajuću energiju prilikom udara u tlo. Stoga su mnogi takozvani meteoriti pronađeni bez kratera, u plitkim kraterima ili zatrpani u tlu. Veći i teži odlomljeni dijelovi kupole su najčešće pronalaženi bliže središtu polja pada, a manje lakši fragmenti su pronalaženi raspršeni na širem području polja pada. Lovci na meteoroite na mnogim lokacijama i dan danas pronalaze pale dijelove kupole za koje misle da su meteoroiti uz pomoć detektora, metala i moćnih magneta. Da bi se meteoroid potvrdio kao autentičan, mora u svom sastavu imati željezo i nikal. Teško je znati točan podatak, ali pretpostavlja se da je u svijetu pronađeno više od 1000 lokacija palih dijelova kupole ili takozvanih meteoroita. Odlomljavanje dijelova kupole nije česta pojava, ali zahvaljujući velikim pronađenim masama postoji značajna količina dijelova kupole u muzejima, privatnim kolekcijama i na tržištu meteoroita. Ako je kupola na crkvi Svetog Petra u Rimu debela oko 2 metra, onda znači da bi kupola koja bi trebala pokrivati površinu veličine zemlje trebala biti debela nekoliko stotina kilometara. To što se odlomio dio kupole ne znači da je na kupoli rupa ni da je ugrožena njena stabilnost. To je kao da se sa stropa odlomio komadić boje. U teoriji heliocentričnog sunčevog sustava u kojem Zemlja putuje oko Sunca brzinom od 107.000 km na sat i rotira oko svoje osi brzinom od 1600 km na sat, matematičke šanse da meteoroid padne 3 puta na isto mjesto kao u Križevcima u Hrvatskoj 2007., 2011. i 2012. godine su ravne nuli. Najlogičnije objašnjenje je da se komad kupole odlomio na istom mjestu koje je već načeto prethodnim odlomljavanjem i pao u krugu ispod mjesta lomljenja. Zašto je nebo plavo ili sivo? Prednji dio kupole okrenut nama, odnosno matrica od željeza i nikla s draguljima je sive boje kada je u sjeni, a plave boje kada je okrenuta suncu. To objašnjava zašto je nebo sivo u danima kada se sunce jedva vidi. Kupola mijenja boju neba u različite nijanse plave ili sive boje, ovisno o količini sunčeve svjetlosti koje prima. Refleksija sunčeve svjetlosti od plave kupole stvara plavu boju neba.
Ovo je jedan komad Brahin meteorita pronađen u Bjelorusiji. Kako ga okrećete prema suncu, on mijenja svoju boju u plavo ili sivo. Unutar ovog bloka nalazi se matrica od željeza i nikla sa draguljima i možemo vidjeti dragulje kako svjetlucaju. Vidimo da je prepun dragulja, sve dragulj do dragulja. U kupoli možete vidjeti osjaj svog lica kao kod ogledala. Kupola izgleda kao staklo, međutim nije staklo jer kada stavite magnet na njega, ono privlači magnet jer ima visok postotak željeza u sebi. Kada se dijelovi kupole sa draguljima okrenu prema suncu, dragulji sjaje u zlatnoj i žutoj boji. Ovi meteoriti se svrstavaju u klasu željeznih i kamenih meteorita. Željezni meteoriti imaju visok postotak željeza u sebi, preko 90%, i veoma snažno privlače magnet. Dok ovi kameni meteoriti isto imaju željeza u sebi i privlače magnet, neki snažnije, neki slabije, ali svaki od njih privlači magnet. Možda na prvi pogled mogu djelovati kao kamenja, međutim, ono što je zajedničko svim ovim meteoritima je da su metali, odnosno željezna konstrukcija kupole. Kamen se nalazi samo u nazivu meteorita kako bi se održala iluzija. Željezo kupole iznimne gustoće i čvrstoće. Ovo je jedan mali komad, teži skoro kilogram. Iako je kupola debela kilometrima, ovakve gustoće nemoguće je probiti. u presjeku ovog meteorita, odnosno odlomljenog dijela kupole, možemo vidjeti sitna okrugla zrna, mineralna zrna zvana hrondula koja mu daju jednu gustoću i čvrstoću. Odlomljeni dijelovi kupole se pojavljuju u različitim oblicima, patinama i različite su strukture, što ukazuje da postoji više različitih slojeva konstrukcije kupole. Jasno je da ova matrica u željeza nikla sa draguljem, koja mijenja boju poput neba i pada je s neba, nije mogla nastati, kako oni kažu, slučajno potonućem težih metala u jezgri asteroida, nego mogla nastati jedino inteligentnom kreacijom jer je stvorena sa ciljem i sa svrhom. Kupola je dokaz da postoji stvoritelj. Postojanje stvoritelja koji je stvorio Zemlju zajedno sa kupolom i sav život na Zemlji se može dokazati znanstvenim metodama.
Vjerojatno nikada niste primijetili jer su vam rekli da se vrtite na letećoj kugli. Ali ako pogledate u nebeski prostor od horizonta do horizonta, možete vidjeti da nebo ima oblik kupole. Možda nikada prije niste išli za tim, ali uvijek kada grmi čuje se jeka, jer se zvuk grmljavine odbija od kupole. Nebo nije prazan prostor i nema plavu boju zato što se, kako kaže službena verzija, sunčeva svjetlost rasipa na različitim valnim duljinama. Jer kada zamrznemo ovu sliku munje u noći, vidimo da je nebo u noći plavo kao da je dan i kada se osvijetli električnom svjetlosti munje, ali i električnom svjetlosti meteora. Možete stvoriti umjetnu dugu ako imate staklo, vodu i izvor svjetlosti. Umjetna duga može biti raznih oblika i uvijek prati oblik stakla. Može biti okrugla, zaobljena, ravna. Kut kupole nam otkriva prirodna duga koja uvijek prati oblik kupole koja na otvorenom prostoru poput stakla oblikuje dugin luk. Refleksija sunčeve svjetlosti od kupole stvara fenomen zvan sunčev prsten. Kada se sunce u svoje putanje približi kupoli, ako promatrate pod određenim kutom, možete vidjeti refleksiju svjetlosti od kupole koja na nebu stvara višestruki odsjaj sunca. U ovom kućnom eksperimentu možemo vidjeti kako svjetlost lampe kada se približi posudi stvara više refleksija kao u pravom sunčevom prstenu.
Glass dome. Earth is not a closed system. Gas dome. The Earth is a closed system.
Oh, glass, you beautiful amorphous translucent mystery. Tell me your secrets.
Oh wow, it's so easy to get one outside. Don't even have to try, man.
This is where the magic happens.